Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the examples in the convolution and the correlation. Examples in convolution and examples in the correlation. So, before going to the examples of convolution and correlation, first of all, you can see what is a convolution, how we can find the convolution. So the convolution is used to find a common area between the two signals. Convolution is used to find the common area between the two signals or two functions. The convolution f of t of time functions f1 of t and f2 of t is designed or defined as f of t is equal to f1 of t with the convolution of f2 of t. The formula is the integral minus infinite to infinite f1 of tau f2 of t minus tau beta, or the convolution obeys a commutative property. Then you can interchange the f1 and f2 also. f2 of tau f1 of t minus tau beta. Okay. The convolution is a mathematical operation. The multiplication is one of the form of the convolution. Okay. So let us take the 25, the multiply with the 25, get the 625. In convolution method, f1 of tau you can take as a 25 and f2 of tau is a 25. And the f2 of minus tau, the f2 of the minus tau and the f2 of t minus tau, they shifted to the right side by the t samples. The t is varied from minus infinite to infinite. But actually the product is different and the convolution is different. Got it, my students? How we can find the convolution for any given two signals? So the first step, the f1 of t and the f2 of t, both the time domain functions. Its formula is the integral minus infinite to infinite f1 of tau f2 of t minus tau beta. Here the independent variable, the convolution integral is tau. So replace t by tau to get the f1 of tau and f2 of tau. f1 of tau is the first function and f2 of tau is the second function, and f2 of minus tau is a mirror image of the f2 of tau. We know that one. The positive values and the negative values is a mirror image only. And third step, the t minus tau represents the function f2 of minus tau shifted to the right side by the t samples, the t seconds. T is varied from minus infinite to infinite. Find the common area between the two functions. Okay, the value of convolution obtained at different values of t and may be plotted on the graph. Now you can follow this procedure to find the convolution of the two functions. Okay, find the Fourier transformation of the given two functions. If the given is a time domain function, it's a convolution of another time domain function because the variable is a t here. The step one, f1 of t is equal to a is a magnitude here. A is a magnitude, and let you take the z10 of t. f1 of tau is equal to a into g10 of tau. A is a magnitude, and we are take changes as the t values as the tau values. And f2 of t, the a into g10 of t, f2 of tau, and a g10 of tau means t also again here the tau is changes. And f2 of minus tau. f2 of minus tau means the tau is negative values, the even function. f2 is given from minus 5 to the 5, the magnitude is a. And f1 of tau is at t is equal to minus tau, means replacing that here the minus infinite to the minus 5 and minus infinite to the plus 5 and minus 5 and the 0. So both we have applied that f1 of tau is a convolution with the f2 of tau, or the f1 of t convolution with the f2 of t. at t is equal to minus 10, t is equal to minus 9, t is equal to minus 8 and 7 and so on. Okay. See, we take here the function as a 10 variable by adding of the two functions, minus 10 to the plus 10, we can take. First of all, if I am assuming them at t is equal to minus 10, t is equal to minus 10, graph both the functions. See, there is no any change in the f2 of t. There is no any change in the f2 of t. Not the f2, it is I think f1 of tau. And only the changes occurs in the ft minus tau is t minus tau function. One you can keep because both are the same only, minus 5 to the 5. In the graph, you can see the minus 5 to the 5, minus 5 to the 5, and minus 5 to the 5, minus 5 to the 5, minus 5 to the 5. One function is always remains fixed, and only we can change the another function. That another function is f2 of t minus tau. What is the t here? Minus 10 plus 5 is for the first value in the positive. We get the minus 5 and minus 10 and minus 5. Replacing here the function minus 5 and the 0 plus 5. At t is equal to minus 10. At t is equal to minus 10 means minus 10 plus 5 and minus 10 minus 5 becomes of minus 15 here and is a minus 5. Both are negative values. So see, the change is here. T is equal to minus 10 means the middle value, it becomes of 0 minus 10. So now you can change these values or minus 15 minus 10 and the minus 5. This exactly we get for the second function when you combine it. Now there is no any overlapping here. There is no any overlapping. This exactly is a minus 5. Now you can take a t is equal to minus 9. T is equal to minus 9 for this same function. T is equal to minus 9. Now it becomes minus 9 minus 5. And here it is a minus 9 and minus 9 plus 5. All the points you can add with the minus 9. Got it, my dear students? So now what happens here? Minus 9 minus 5 becomes a minus 14 and minus 9 and minus 9 plus 5 is now it is a minus 4. So it moves towards the right side. Moves towards the right side. Already the minus 5 to the 5 is there. Now we'll get in the minus 5 and 4. There is a overlapping occurs here. It's a overlapping. Wherever the overlapping occurs, you can take the limitations of those values. Limitations. What is the limitation here? Minus 5 to the 4. So apply the integral minus 5 to the minus 4 a into here one signal having the amplitude is a, other signal amplitude is also the a into a square into d tau. So with respect to the tau we are taking. So a square into tau means that a square is a constant value. The tau 1 in d tau is the tau. Minus 4 plus 5. So upper limit is a minus 4 here. Lower limit is the minus 5, and we use for the lower limit you can substitute the minus of minus 5 is a 5, and we get the a square. Okay, my dear students, a square is a magnitude. Now the same way you can take the t is equal to minus 8. T is equal to minus 8. Still you can move towards the right side. Still you can move towards the right side. Okay. Now it becomes the 0 value is at minus 8 and minus 8 plus 5, minus 8 minus 5. What did my students? So minus 8 minus 5 is a minus 13, and minus 8 minus 3. So now we can still it is moves. It had the minus 14 and now it is a minus 13. It's a minus 13 minus. Minus 8 and minus 3 is a graph for the shifting value. Already there is no any change in the minus 5 to 5, another signal. Here they see there is no any change in this one. The first one there is no any overlapping, only this function is moves towards minus 15, minus 14, minus 13, so on. Now what is the limitations here? Minus 5 to the 5, 3, A and A is the amplitude, and d tau. Now it becomes of 2a square, because of I minus 3 is a 2a square. Previously it is a square. Still it is moves. So minus 15, minus 14, minus 13, next is a minus 12, minus 8 becomes a minus 7, and minus 2. So here the 0, minus 4, minus 3, minus 2, and so on the minus 1. Means still it is 2a square, 3a square, 4a square. What it might be? Still you can move. There is no any overlapping up to the values. At t is equal to minus 10, minus 9, minus 8, minus 7, minus 6 goes on increasing the value, decreasing the increasing the values. Minus values here. Minus 8 is more or less than the minus 7. Goes on increasing the values. 0 here, its magnitude, and let us take the a square from the 0. So 1a square, 2a square, 3a square, and 4a square. Then after at 5, t is equal to minus 5, minus 5 to the 0. How it is, again I will explain. At t is equal to minus 5 means the graph is varies from the 0 to y plus 5. Now I am taking the t is equal to minus 5 means minus 5 minus 5 is a minus 10. 0 minus 5. And now it is a plus 5 and the minus 5 here is a 0. So the limitations is from minus 5 to the 0. Minus 5 to the 0, a square into tau. Tau is 0. And lower limit is applying the lower limit. Limitation is minus 5 into 5 is a 5a square. Next it is a 6a square, 7a square. Okay. Then 8a square, 9, 10. Now whenever we get to the t is equal to 0, minus 4, minus 3, minus 2, minus 1, and the t is equal to 0. T is equal to 0, both the signals are overlapping at the minus 5 to the 5. Got it, my students? We have started at the 10 is equal, t is equal to minus 10. Minus 10, there is no any overlapping. If it is a minus 11, means minus 16, minus 11, and the plus 5, minus 11 plus 5, minus 6 will get. There is a gap is there between of the two signals. So that I took that is after t is equal to minus 10. At t is equal to minus 10 up to the t is equal to 0. It starts from the a square to the 10a square. Okay, then after still I am further moving that it's a t is equal to 1, t is equal to 2, 3, and so on. So again here minus 5 to the 5 value 0 and the 5. Previously it is a t is equal to 0. Now the t is equal to 1. T is equal to 1 minus 5 plus 1, 0 plus 1, and 5 plus 1. Means it is a minus 4, 1, and the 5 minus 0, 5 plus here the plus 1 only. 5 plus 1 is a 6. See the minus 4, 1, and the 6 moves towards the right side still again. Now the overlapping is occurs at the minus 4 to 5. Minus 4 to 5, again it is a decreases. 9a square, 8a square, 7a square, 6a square, 5a square, and the 4a square. Still it goes on, moves -4, -3, -2, -1, 0, and 1 and the 5. Still you can move that t is equal to 7 also. T is equal to 7. T is equal to 7. Now I will note here that T is equal to 7. T is equal to 7 means the graph look like from -5 to the 0 and +5, -5 plus 7, 0 plus 7, and 5 plus 7. So what happens is 7 minus 5 is a 2 minus 2, 7, and 7 plus 5 is a 12. So it starts from the -2. It's a minus, not the minus, sorry, it's a +2, my students. So +2, 7, and the 12. See here the 0, 1. Now the graph is look like this value is 2. Still goes the 2. And it is a 7 and 12. 2, 7, 12. And already there is no any change here, the -5 to the 5. Here the 5, -5. The 5 is there. Now the overlapping is occurs at 0 to 4 and the 0 to 5. And here the -3 to -4 2 and -5 5 up to so on. Still it is a 2 to 5. Now the overlapping is in between 2 to 5 on. Okay, 2 to 5. So the integral 2 to the 5, a square you'll already have, a square into d term. That is a square into upper limit is 5 and lower limit is 2, means a square into 5 minus 2. That will get the 3 square. 3a square, sorry. 3a square. Previously it is a 4a square. Still you can move the t is equal to 7. T is equal to 7 means t is equal to 7, I did here, and t is equal to 8. T is equal to 8 means 8 minus 5 is a 3. 3 and 8 and 5 plus 8 is 13. So still is moves towards right side 3 to 5. So the range is now the a square 3 to 5 d tau. So a square into tau 3 to 5 here. 5 and the 3. 5 minus 3 is a 2a square. Again, you can move still a square into 3 to 5. 2 to 5, 3 to 5. Now it is increases of 4 to 5. 4 to 5 d tau. Means a square into tau 5 and the 4. So 5 is upper limit and 4 is the lower limit. Now it is a square. Again, the t is equal to, this t is equal to 7, we got t is equal to 8, t is equal to 9. Now we start from the -10 to the 10. T is equal to 10, what happens? T is equal to 10 means -5 plus 10. Okay, t is equal to 10. -5 plus 10. 0 plus 10. And 5 plus 10. Means here it is a -5 plus 10 is a 5, 10, and 15. So the graph is already, we have one graph is from -5 to the 5. With the amplitude is a, the 0. Another graph started from the 5 on. 5 and 10 and 15. So 10 and the 15. Now there is no any overlapping occurs here. There is no any overlapping. So start from the 0, a square, 2a square, and so on up to that 10a square. Again, it is a decreases 9a square, and so on 0. Symmetrical. Got it, my students? Again, I will see here. At t is equal to 10, there is no any overlapping. T is equal to minus 9. We got the a square is the amplitude. Overlapping only from minus 5 to the minus 4, minus 5 to the minus 3, minus 5 to minus 2, minus 5 to the minus 1, minus 5 to the 0, and like that you can go on increasing the values. 6a square, 7a square, 8a square, 9a square, and 10a square. After that, again, both are overlapping at the minus 5 to the 5. Still, it is moves towards the right side. 9a square, 8a square, 7a square, 6a square, 5a square, and 4a square, and 3a square, 2, and so on. Okay, t is equal to 7, 3a square, t is equal to 8, 2a square, t is equal to 9, a square, and t is equal to 10, it is a 0. So from minus 10 to that is a increasing the value at 0 the 10 square, and again it is decreases the value. Got it, my students? All the values what we got at t is equal to minus 10, 0, minus 9 at minus 9. The amplitude is a square. Here let us take it is a square, 2a square, 3a square, so on. It is a 10a square. Again, it is a 9a square, decreases 8a square, and so on. It is a 0. Okay, both are it is a symmetry. Plus 1 minus 1 values is the 2a square. Plus 2 and minus 2 both are same values. At minus 10 and plus 10 also the 0 value. Minus 9 plus 9 is amplitude is a square only. In both the cases. See, the t is equal to 9a square. T is equal to minus 9 is also the a square. What it minus 2? The graph of the given minus 5 to the 5, one signal f1 of t and another signal f2 of t, both are it is amplitudes is same, and the frequency is also the time period is also the same, from minus 5 to the 5. Its convolution will get as a symmetric like this, from minus 10 to the 10, because the maximum values are minus 5 plus 5, minus 5 is a minus 10, and 10, 5 plus 5 is a 10. So you can take from minus 10 to the plus 10. Got it, my dear students? It's a very important examples, this one. Now you go for convolution. That is a graphical representation to find the convolution. Mathematically, the way of combining the two signals to form the third signal, that is input signal, the output signal, and the impulse response. It is used to express the input and output relation of a linear time invariant system. The two functions x of t and y of t in the time domain are defined as a convolution. Minus infinite to infinite x of tau y of t minus tau d tau, or read it as a convolute with y of t. Okay. Convolution in time domain. The convolution in time domain is equivalent of multiplication of the spectra in frequency domain. Okay. Means x of t is x of omega and y of t the y of omega. X of t with the convolution of y of t is x of omega into y of omega. So it is one of the property in the Fourier transformation. Convolution in time domain. Got it, my dear students? I'm not explaining this again. This is a time convolution theorem. And convolution frequency means this is a multiplication method of the modulation theorem. These also I'm not explaining here, because already we did these two. Now, take one example in the graphical representation. How can find the convolution So next we can see the graphical convolution. The convolution by inspection provides the information needed without the complicated calculation. This convolution by inspection procedure is called the graphical convolution. Forget about this definition. And how you can find out the convolution by using the graphical representation. First of all, x of tau is a first function where an independent variable t is replaced by the dummy variable of tau. And y of minus tau is a mirror image of y of tau is flipped. And y of t minus tau represents the function of y of minus tau is shifted to the right by the t seconds for a particular value of t is equal to a, integrate of product x of tau y of a minus tau. The t, instead of t, you can take the a, or you can keep the t also. Nothing will happen, my dear students. Okay. Now, find the convolution of the functions x1 of t and the x2 of t. See here the x1 of t given a rectangle function from -1 to the 1, and x2 of t is given its magnitude is a, and from 0 to the 4, slowly it is increases up to the value of a. Got it, my dear students? Now, first of all, I need to find the y of t. Y of t is equal to the convolution of x1 of t with x2 of t. What is the x1 of t? X1 of t is from -1 to the 1. X of t is the same here, x1 of t, and x2 of t is a linear function from 0 to 4. The value is a at the 4. 0 to 4 only the variable for the t. Now, what is the formula for the convolution? Integral minus infinite to infinite, x1 of tau, x2 of t minus tau d tau. Means the t is variable here, the y of t. I need to find a t is equal to 0, y of 0 is equal to integral minus infinite to infinite, x1 of tau, x2 of the t value is 0, 0 minus tau d tau. That is equal to integral minus infinite to infinite, x1 of tau, x2 of minus tau. The folded function, x2 of minus tau. See here the y of minus tau, because they are taking that, it's x and the y is a mirror image. Mirror image means now you can change that graphical representation as a positive value. Now it goes to the negative value, -4 to the 0, because it is a mirror image, -4 to the 0. Exactly the mirror image will get like this. Or you can say it is the folded function. Simply whatever there in the positive real axis, you get in the negative real axis. Is x2 of t. Now, see that x1 and x2, there is no any overlapping. It is start from the -4 to the 0, and here it is a -1 to the 0. Okay, -1 to the 0. Again, you can draw this here. Definitely there is a -1 to the 0 is there. -1, let us draw -1 to the 1. Okay, here this part is overlap. This part is a overlap. So -1 to the 0. -1 to the 0. Again, you can shift the t is equal to 1. T is equal to 1. The t is equal to 1. what happens when t is equal to 1? Y of 0 becomes integral minus infinite to infinite x1 of tau x2 of t. Now it becomes of 1 minus tau d tau. Means the folded function is shifted towards the right side with one sample. So x1 of tau, x2 of take the minus here, the minus part of take the common, tau minus 1 d tau. So x2 of minus tau, the 1 value is there, minus of minus is a 1. The folded function is shifted to the right side. Now the graph look like there is no any change here in from minus 1 to the 1. X1 of is the same, x1 of t signal. Now the value is shifted towards the right side of one sample. Already here the minus 1 is there, minus 4 is there. Now it becomes at the minus 3. It starts at the minus 3. Okay, minus 3. And ends at the 0 is also shifted to the one sample. Means add the 1. You'll get the value like this. Now the overlapping occurs here. In this part is a overlap. Minus 1 to the 1. Here previously it is a minus 1 to the 0. Now it is a minus 1 to the 1. So it goes on like this to get the value. So there is a overlapping occur. Still it is a overlapping, goes on increasing. Minus 1 to the 1 and minus 1 to the 0. Again it is a 1 also, because still it is moves. Previously I told that t is equal to 1. At t is equal to 0 and the t is equal to 1. Now it is a t is equal to 2. Nothing but a is equal to 2 and a is equal to 3, or t is equal to 3. Now we'll draw the graph that also, and t is equal to 2 means the x of x2 of minus of 2 minus, or the 2 minus, okay, t is there, the x, I will write the formula again. The y of t is equal to integral minus infinite to infinite x of tau, x1 of tau, and x2 of t minus tau d tau. We need to find the t at t is equal to 2, integral minus infinite to infinite x1 of tau, x2 of 2 minus tau d tau. So what is that 2 minus tau d tau? The integral minus infinite to infinite x1 of tau, x2 of take the minus now this common, tau minus 2. So it moves towards the right side as a samples. Already we have from minus 1 to 1 of x1 of t. So previously from minus 4 to it changes to the minus 3. Minus 3, now it changes to the minus 2. So it started at the minus 2 here, minus 2, and ends at the minus to the 0. 0 means the value is also here, it's a 2 on, up to the 2. It's a graph. So now the overlapping is here itself on. Okay, my dear students. Still you can move this one. Minus 2 is shifted at the minus 1. Minus 1. And getting at the 2 is a 3. Now again it is a overlapping of the set minus 1 to the 1 only. Minus 1 to the 1. The overlapping including this also. Minus 1 to the 1. Still you can move that. The graph is look like from the 0 to the 4. 0 to the 4. It is from minus 1 to the 1. Okay, minus 1 to the 1. There is a changes. Okay, my dear students. So now by using these values, they draw a graph. It looks like from minus 1 to the 5 value. This is just like the curve, varies from -1 to 1 and the -2 to 1 and -3 to 1 and -4 to 1, like that. Got it, my students? Given it is a continuous time function, we can draw the graphs also in the continuous time function. Got it, my students? Then the convolution between these two functions will get as a curve from -1 to the 5. Got it? The another function here, another example, determine the response of linear time invariant system where whose input x of n and the impulse response h of n is given, x of n and the h of n. Find the convolution. X of n, graph is here at n is equal to 0. Starting the arrow mark means at n is equal to 1. N is equal to 1, the value is 2. N is equal to 2, and the value is 3. And n is equal to 3, the value is 1. Okay. And h is also given. Arrow mark representing at the 2 means the value is -1, the value is 1. At 0, the value is 2. At 1, the value is 1. And at 2, the value is a -1. Okay, my students. So there is no any change in the x of m, only the folded function you can take it, folded function at the 0, -1, whatever the value at the 2, now you'll get it the -2. The value is 1, at 1, the value you will get it the -1. At 0, the value is 2, there is no any change in this value. Now the -1 value you get at the 1, its amplitude is the 1. Now you can multiply these two functions. At 0, the value is 1 and 0 is a 2. So 1 into 2, 2 plus, and at 1, the value is a 2, the value is 1 at the 1 only. The 2 plus 2 into 1, the 2, you get the 4. Okay, my students. Whenever if it is t is equal to 0, the t is equal to 0. Or n is equal to 0, not the t, because the t we representing in the continuous time function. The value is now the 4. Because these two functions only the overlapping. You can multiply the magnitudes. 1 into 2 here, 1 into 2, here the 1 and 1 into 2, here the 2, here the 1. 2 into 2. So 2 plus 2 is a 4. Keep that as a 4. Okay, my students. That is for y of n is equal. One value you got the 4. Still you can move that value towards the right side of one sample. See, these are moving towards the right side of one sample. The graph -1 will get at the -1. -1 value it at -1 and 1 it is at 0. And it 2 at 1 and it 2 at the value is a 1. Means one sample is shifted towards the right side. That is h of minus of m minus 1. One sample is moved. So again here there is a three values will have 1, 2, 3 is the magnitudes. Here 1, 2, 1. So 1 into 1, 1. 2 into 2, 4. And here the magnitude is a 3. 3 into 1 is a 3. So 8 is another value. Okay, 1 into 1, here the magnitude is 1. And 2 into 2, 4. And here the 3 is there. 3 into 1 is a 3. Understood, my students? Further, you can move like that 4, 8. Already we got the 4, 8 the value. See the 4 first one. Second one, the value is 8. 1, 4 plus 3. Okay. Then still it is moves towards the right side of y of n. See the -1, 2, 3, and 4. It multiplies with the x values. You see, the 0, there is no any value in here, 1 into 0. And 2 into -1. 2 into -1 is a -2. And at 2, the value is 3. 3 into 1, 3. and at 3 there is a 2, 2 plus 1, 2 into 1 is a 2, the value is a 3. Now we got the value is a 3 at n is equal to 3. At n is equal to 4, n is equal to 4, again still it is a moves towards the right side. The overlapping values 2 and 3 on. 2 and 3. At 2, the magnitude is a 3, nothing but minus 3. At 3, the magnitude is a 1, and here it is a 1 plus 1. So minus 2 is a value. So minus 2. Okay, my dear students, we got the 4, 8, 3, and minus 2. Still, you can move towards the right side. Only the overlapping occurs at the 3 into 1. 3 into 1. 3 into minus 1, my dear students, so minus 3. So whether we are getting the values, whatever we got, the same or not, let us examine that. What is the given here? X values. X value is 1, 2, 3, 1. 1, 2, 3, 1. H values are 1, 2, 1, minus 1. Okay, multiply these values. Minus 1, minus 3, minus 2, minus 1. And 1 to 1 is a 1, 3, 2, 1. And multiply with the 2. 2, 6, and 4. And is a 2. Again, it's a 1 is a 1, 3, 2, 1. So many values we'll have to get. Here the 4 values are there, and the H value is also the 4. Means totally M number of values, M plus N minus 1 number of samples you have to find out. What is the X is nothing but number of samples in the X value is a 4. And how many number of samples here in the H? Nothing but is a N plus 4 minus 1. So 8 minus 1 is a 7 samples you have to get. We already find out the 5 only. Okay, means before that there is a 2 values there. Before the 4 means that T is equal to minus 1 and the T is equal to minus 2 is also you have to find. Got it, my students? We started at n is equal to minus 1. Okay. And before that values also you have to find out to get the values is a minus 1 here, minus 3, and 3. Okay. So again I will explain properly the 1, 2, 3, 1 and multiply with the 1, 2, 1, minus 1. Can multiply this a minus 1, minus 3, minus 2, minus 1. With 1 multiply 1, 3, 2, 1. With the 2, 2, 6, 4, 2. And with 1, 1, 3, 2, 1. See the values is a minus 1 here, minus 3. 2 plus 3 is a 5, 5 minus 3 again is a 3. 6 plus 2, 8, 8 plus 1, both are cancelled, 8. And 4 plus 3 is again, it is a 8 here. 2 plus 2 is a 4 and 1. So 1, 4. Here the arrow mark is at minus 1. Before the arrow mark is a 0. Can keep the arrow mark, the value here, 1, 1, 4, 0, 8. So at n is equal to 0, the value you get, and n is equal to minus 1. Minus 1, the value is a 1. See the y of minus 1 is equal to 1. Okay. And then after, y of 1 is equal to 4. So see here the y of 0 is equal to 4. Y of 0 is equal to 4. Y of 1 is equal to 8. 8 we got here. Next value is also the 8. Y of 2 is also 8. And y of 3 is equal to 3. And y of 4 is equal to, sorry, here the minus 2 only. Minus 3 minus 1 is a minus 2. minus 2, and the last value is a minus 1. That is the value at n is equal to 5. N is equal to 5 minus 1. So 14883 minus 2 minus 1 is the resultant value for the given discrete function of x and the h value. Is the only verification method of my students. Graphical representation method means must and should you have to draw the graphs and multiply the magnitudes at all the values of t or at the values of n in the discrete functions.